Hello and welcome to week 4. We're a month in. I can't believe it. Things are going by really quickly. It just seems to be the way of the world today. Before I dive too much into this lecture, there's a couple things I want to cover. So far, everyone's doing well. All the homework you submitted, everything has been top notch. I will try to provide feedback if you ask about a couple students we've met one-on-one. If you have questions, please feel free to contact me. That is why I'm here. I'm here to help you on your path. Um, as I said before, I think this is probably one of the most important topics in computers, and it's also one of the most difficult because it's not a straightforward path. You know, when we learn SQL or when we learn C or Python, well, there's many different ways to learn it. Python still inherently has rules, and there's a lot of good books, there's a lot of good information. That's not necessarily the case with business intelligence. It can be a little bit more, you know, loosey goosey, I guess. And I hate to use that word, but it's very true. Some people learn business intelligence because they have an MBA and they went into the data analytics side. Some people learned it because they're nerds. They know the SQL, they know the Python, and business kept asking them questions, and they grew together. So it's it's a hard but very vital tool. This class will help you immensely, and not just business, but in almost any endeavor you do. So this lecture is not going to be super long. This week's going to be a little lighter. I'd like you to work on your research project. I made a video. At the end of the day, the research project is just some type of proposal. You don't have to do any analysis. A couple pages is fine. Don't worry, you can do APA citations if you use links, or you can use MLA or Chicago. I don't care. What I want from you is, here's a problem, here's data, and here's how we can solve that problem, and here's how I give back to you, the company, the world, something else like that. There is information on Web Campus. If you have questions, please let me know. Again, I'll be happy to read a draft of it, but please make sure you get that draft to me 5 days before it's due, 5 days before the end of the month. This week I posted a couple videos in the reading section, so they're LinkedIn Learning, Linda. These are the more relevant ones. If you know Tableau pretty well, you don't have to watch them. So when I say, let me pause this. When I say managing data source, about 25 minutes, and managing Tableau worksheets. So that would be, let's see if I can make this a little bit bigger. I mean, you can watch the rest of these. That's totally up to you. But a lot of in theory, you have Tableau installed already. You have a lot of this done. So managing data sources is these right here. I love the splitting text to multiple columns. I have 2 different accounts, so I can watch on the other one. Then managing tab, and you don't have to worry about the quiz. You can just skip it. Adding and duplicating worksheets at the very bottom, reordering, clearing, things like this. Save your work. So these are really only 2 things that you have to watch. And this just gives you a real good primer on LinkedIn. There's other Tableau courses. The nice thing about this is he's using 2023.1, I believe he said in the first video. I think we go here. So this relatively new version, and Tableau changes, 2023 right here. I think it's 0.1. And Tableau changed a lot. There's a lot of other videos on Tableau. A lot of them get older, and some of the technology changes. So that's the reading and learning part. And then also this. Oop, nope. This one. It's also LinkedIn Learning. Now, this is stop. You can just watch, what did I watch? Introduction to Lean Sigma 6. And this guy, Steve Brown from ASU, has other videos you can watch or other courses. This gives you a really good foundational aspect or understanding of what Six Sigma is, what Lean process is, and why it's important. And it's especially important in data analytics. And I'll explain why here in a second when we actually get into the course. So this is, you just read this guy. I love the part right here. Identification of the problem. Where does a problem derive from? What's the root cause? And I believe it was 2 weeks ago, we had a discussion about data problems, things like that. And some of it was date time. Hey, the date time's different. We have bad data. we have incomplete data. Well, the idea of this is how do we fix that? I think I should just read down to uh, right here, the levels. After down below this, don't have to worry about it. I didn't talk about I think it's Pareto chart. They're super helpful. They're an 80-20 rule in charts, and they're super helpful. I use them all the time, and I highly recommend them. They don't fit every situation, which we'll talk about, but they're super nice. What else? So this is another article. Hey, brainstorm the 5 whys. Why did this happen? Why did that happen? And what can we do to prevent that? And again, because if we didn't have problems, we wouldn't have reports at the end of the day. So that was that. There's that. You got this. This. So I'll post this. Also, on the Sigma 6, he talks about. I think it was this video. He talks a little bit about standard deviation math. Don't worry about the math. I'm not worried about you guys learning math. I'm more worried about you learning the overview. Also, he talks about waste, but he doesn't cover waste wheel. This is a waste wheel. You just Google waste wheel. I think it was the first or second one that came up for me when I Googled waste wheel. We do these often. When we're looking at process, I have to define a report. I have to create a report for why. Where's a waste? Where's the failures? Okay, is it poor engagement? Is it too much inventory? Not enough inventory? Is it moving things? And I got a picture of this where things move. And when I say moving things, I'm not talking, at least for me, about physically moving things. Okay, when I talk about moving things, I'm like, hey, I made a copy of a student's name into this system and then to this system, and then I enter a grade in this system, and then I have to do this, and it's very inefficient. Okay. I go over referral process. When we get a referral order, I evaluated that, and you see there's a lot of areas in which there's a lot of waste. So my screenshots that I took was kind of small, but I think you'll get the idea. So let's get started. Oh, one more thing. I'm not going to share this because I'm not sure where I got it from, but I think it will provide some help. I got, I think, 1 or 2 questions about databases. I just kind of wanted to review databases. Make this full screen. Sorry, my mic's in the way. There we go. Okay. So just a real quick review on databases. Since databases are such a big part of what we do, most data is stored in databases, which ironically go to Excel, and sometimes we analyze that Excel and put it in another database, or sometimes we get that Excel, reanalyze it and put it out to another Excel. But at the heart, a lot of what we do is in a database. And so storing all information as a single row becomes repetitive. So that's why we break things down to relations. That's why we normalize the data. Now, what I like about this is right here. Database workloads. An oltp, transactional processing, versus AP, analytical processing. What is inherently the difference? And I alluded a little bit to this, is that a TP, a transactional database, is forward-facing. I think that's the term I use, forward-facing or customer-facing. And they say user-facing. So that means it could be a cash register. That means it could be a license plate scanner. It could be some type of system that the production and the machines use to store data. Okay, typical applications: e-commerce, banking, airline reservations, user-facing, real-time, low latency, high concurrency, high multiple users. Tasks: relatively small set of standard transactional queries. That means it just does the same thing over and over again. It does it really fast. Random reads, updates, right, blah, blah. Okay, now analytical processing, and our analytical process database, has more business intelligence, data mining, okay? So these queries might be much longer in terms of time. That could be bad for a system that's not designed that way. Back-end processing, batch workloads. We can write some type of Python script or Alteryx script or some type of system that every Friday night it does X, Y, and Z. So that would be a batch process. Yeah, most databases operations involve online transactional processing, short, simple, frequent queries. Hey, this customer passed us, this customer did this customer did this. When we're a bank and you deposit $15, that's just one line. When you want to know the average amount of all the deposits for the last month, you have to take 1 million customers times maybe 5 million different, not really times, but 5 million different deposits and start doing an average, and it gets really messy. So that's a difference. A transactional database is designed for short, frequent interactions. An analytical processing, AP, designed for more longer analytics. Hey, what's the average of all the deposits? Per zip code, what's the average per zip code of the customer depositing the money? What's the average deposit? Okay, so if we look at the database, we know that Amazon tracks every purchase that we do. Purchase, purchase, purchase. So they have a database that tracks all that. Now, as an Amazon CEO, I'm Jeff Bezos, or an Amazon executive, we want to be able to use that information to say, hey, you bought 3 books on databases, maybe you want another book on databases. But to do that, we have to analyze your whole purchase history or your whole purchase history for the last 6 months, whatever relative time frame we want to use, and then say, hey, we know you bought these 3 books, maybe you want to buy this other book. That is a much longer process. Instead of just saying, hey, you bought this, you have to analyze your whole history. So what else was good here? And in theory, you can run transactional and analytical process on the same machine, but there's pros and cons to that. Small business, 10, 15 people, that's really realistic, and that does happen. Big companies, millions of people, or maybe not millions, but hundreds of thousands of people, probably doesn't happen. We just kind of talked about this. And one of the reasons we do that ETL, which we covered last week, is we want to normalize time frames. And remember, this transactional process, even though it's one block, it doesn't have to be one block. This could be 5 or 6 or 10 or 20 different data sources, databases. Okay, so if you had, I want a list of all my deposits by zip code in the Las Vegas area, and I'm Wells Fargo. So I want to know zip code 89123, the average deposit is $100. 89124, average deposit is $180. 89125, the average deposit is $12. So that's the type of information I want to know as a, I don't know, Wells Fargo executive. Well, I might have all those individual deposits from each individual bank in a database. We have to extract all those, and maybe we just kind of summarize it somehow. This branch had this many deposits for this day. Or this customer, if you're a business, you might have multiple deposits in a day. This business did a total of $800 in deposits on this day. This business did a total of $900 on this day. So we might summarize or aggregate that data before you load it up to Southern Nevada Regional Database for Wells Fargo. So that's kind of why it's important to understand the difference. And, the AP analytical processing databases are for data warehousing most of the time, not always, but most of the time. We're using for business intelligence reporting, on-demand reporting, data mining, things like this. And in terms of data mining for this, it's not the same as in past classes we've taken programming and you see a website and you want to pull that data down. That's the same process, but different type of data mining. This data mining is maybe more intelligent mining, where we say, how can we find additional revenue opportunities? How can we find additional ways to make money? So let's see. I think that's most of what I want to cover with this little PowerPoint. I wish I could remember where I got this PowerPoint. It's a great PowerPoint. I don't remember if one of my instructors provided it to me. I don't know if I was doing outside research. I just know that I have it, and I love it, and whoever made it is a genius, and I appreciate them. Oh yeah, it goes into star schema a little bit here. Let's go down here. So we talked about the star schema. Where's facts tables? Okay, correct. It's facts tables and dimensions tables, or I call it, your data and your metadata. Different words, and maybe metadata is not the correct term. That's just the way I've learned to think about it. But you have something of value, and you have things related to that value. I'm a human. I'm Richard. I have no hair. Right? The no hair fact, that's metadata about me. I'm 6'3". That's metadata about me. Okay? The fact is I'm Richard Young. The metadata, or the dimensions, explains me. So if we go in here, it says, hey, if we had a list of all the bars, okay, so bar number 1, bar number 2, bar number 3, I don't know why they do all the alcohol, but hey, if I had that, I might have additional information. I might have dimensions related to the address. I might have dimensions related to its yearly licensing. If I had beer, if I did beer sales, so I wanted to, if I was Lee's Liquor here in Vegas, I might have a list of beers, and then who made that beer, the sales of that beer, things like that. And let's actually see that a little bit more in detail. I have a nice little picture here. Sales, related to sales, who bought the sales. If you just need to know how many customers bought products, you don't really need, well, you might need products, but you really just need sales and customers. You want to know your busiest store, but you don't really care about customers, you just join these two. If you want to know what store sold the most product, you need this table. What store has the smallest customer base? You need these two. So it's really how we want to join the data. And remember the star schema, the star structure, the star outline. We use that, or database admins use that, or programmers use that to make querying the database easier for us, the business intelligence person, the data analyst, the data scientist. Okay, so it's just a way of structuring the data to make life easier for us. I took this class, what the name of class? MIS 123. And in that class, we had a chapter on this, and then we had other students that helped me this. So there's just a way to organize our dates, our information. This thing gets into some other stuff which I really don't want to cover in this class because I don't think it will be of a benefit to you right now. A waste wheel, super important. We'll talk about that. So let's go into this. Okay, what do we have this week? Okay, so the second week, the SQL week, we talked a little bit about, I don't want to say data in the wild, SQL. We don't know if that necessarily is good or bad data. We don't know the validity of it. With that Craigslist car thing, we had a lot of ads that were zero value. If you were doing an average, that would throw us off. We had a lot of not invalid columns, but data that I would not normally use. We had Chevys, I think it was Chevys or Toyotas, that were for sale on Craigslist for 1,200,000, 1, 2, 3, 4, 5, 6, 7. There was a price. So data in the wild. The extract, the ETL part, we pull that data down and we kind of derive intelligence from it. Some of your guys' classes or all your homework was amazing. I saw a max min to try to analyze potential profit. Hey, buy low, sell high. I saw one state to another state arbitrage. That's such a hard word for me to say. Well, hey, I buy it in this state and I sell it in that. I saw, hey, let me buy this type of vehicle and see if I can rebrand it in another state. Not rebrand it, but hey, if I buy a Toyota here, is Honda's going to be in the same state, going to be popular? I mean, just a lot of amazing little ETLs. And then we did the Tableau, or I think it was last week we did Tableau, and we kind of dove into that a little bit more. So this is kind of this week's idea. We're going to talk about reporting. This week's going to be more, again, conceptual. And the reason for that is because, again, with the other discussions with bad data, we have to figure out why we're getting the bad data. We have to figure out what we can do to prevent bad data. We're going to have to figure out what type of reports people want from us. What do I really mean by reports and queries? And that's a great question. So let me just start here. So business intelligence is about communicating knowledge and information to achieve a goal. Okay. Now, a lot of time, a lot of the reporting is one-time random ad hoc reports. Hey, Richard, can I get X, Y, or Z? And you have to think, when you have those one-time reports, you're going to approach those and attack those differently than you would if you have a report that you're going to develop over 6, 8, 10 months. Okay. Um, hey, student, I need to know how many Toyotas are available for sale today in the state of Missouri. I need to know how many Ferraris I can buy in California, or I need to know how many Ferraris was sold last month in the state of California. Things about, those were one-time requests. Now, as an executive, if I own some type of car company, I might be more interested in what states can I make the most money in? Is there a seasonal bias in one particular state on my Craigslist data set? Or do I notice that in the month of June or July, maybe people sell convertibles and they buy them in January and February? I don't know. Do people normally, let's say there's a lot of childbirth in September, October, and November. So that means people are buying a lot of minivans before those months to anticipate childbirth. Those are more executive or strategical or long-term types of reports. So let's see what else we have. So now, it is always hard to try to come up with reporting tips. So a couple of big picture tips I can give you is always remember the audience and remember the purpose. So if I have a report that I need to send over to financial analytics, they love Excel. If I send them a PDF, they will not be happy. Even if it's the same report, they don't want PDF, they want Excel data. So they'd rather have less visualization, generally speaking, and they want more Excel data. If I send a report over to a doctor, he generally doesn't want Excel. He wants a PDF. He wants a purpose or a goal. Okay? So who is my purpose? Who is my audience? I recently had a request from a COO, CEO of one of the big companies, multi-million-dollar guy, and I gave him just like 3 lines and a very plain table because he wanted to know one particular fact. I provide that fact and that's it. Now, I provided a report to another CEO, I think 2 months ago, with very similar data, but it was a trend because it was him reporting to his boss, the CEOs often have bosses, how he is growing his market. So who are you giving the report to? Always try to keep that in mind. What is their computer literacy? What is the purpose of the report? And there's a way to think about it too. Is it reporting past data or is it trying to predict future data? Okay. Do I need to know sales the last 3 months so I can pay tax on it, so I can look at my inventory, whatever purpose? Or do I want to know my sales for the last 3 months to know where to spend marketing for the next 2 months? Generally, when you can, have as little text on the report as possible. You want to have scales and you don't want to shortcut your report. But often I see people putting a lot of extra data on the reports. Maybe they have a graph and they have some other text or information about it, and they put on a page of data. That's not necessarily that's not necessary often. Sometimes it is, sometimes it's not. And then again, if we're forward looking, what is your recommendation? So I came up with these and I saw a couple of these. I think there's I saw another one that somebody had strategic reports and tactical reports. So just in my mind, this is the way I think about it. Ad hoc reports. These are the one-time as needed reports. So I think somebody in here works in a restaurant. So an ad hoc report says, hey, I need to know how many fish sandwiches I sold last week. It's just a one-time request. I don't ever need to know again, or whatever. It's just these one-time odd reports. A health inspector came in and he needs to know X, Y, and Z. It's an ad hoc report. Operational reports. So your operational reports are generally for your mid-managers or your business managers, is another term to use, and they look at day-to-day reports. How many staff members do I have right now? How much is my salary for those employees? How effective are those employees? Now, a management report, I consider these more higher level in terms of operational reports. a mid or a management report or KPIs, um, they show, is my business growing month over month? Am I getting new referrals month over month? You know, if I owned that business, if I was responsible for that business, what would I want to help me drive new change? So if I said, hey, I need 3 more employees, and you come back to me and say, why do you need 3 more employees? And I pull up our little, well, look, my sales are going up. I have more sales right here. My KPI shows I'm having more sales. And so since I have more sales and I have more referrals, I need more I need more employees. Now, executive dashboards, those are generally more focused, and they're often, sometimes I think they can be called strategic dashboards, but they're, where do we want the business next quarter? Where do we want the business in 2 quarters? I don't necessarily care maybe about the number of employees. I don't care about the number of products. I want to know these 3 metrics to me are of what basically I report out to either shareholders or to whoever, and these are the metrics that I want to track. Regulatory and compliance reports has become a bigger and bigger thing every year. These can vary all over the place, depends with industry. On gaming and slot machines, I sold this many machines to this company, and they rebooted X number of times. I sold, we had this many payouts that we have to send out to the state of Nevada, and this is how much players played. Okay, so these are very I don't want to say canned, but very predictive reports. We do a CHIA report, which I can't even think what it means. But so each month we say, hey, this is how many charity cases we have. This is how much money we've spent on charity. This is how many people we have in different locations. This is how many chaplains have helped people. So those are examples of compliance and regulations. Predictive and forecasting. This is one of my favorite right here. You'll find a lot of reporting is looking at the past, trying to figure out what we did. And that's just the way business is. You know, if you're always, let's talk about relationships. If you're always looking in the past, you're never going to go forward. And a lot of businesses look in the past, trying to figure out what happened. What do we do? How can we make things better? The way I see a lot of it, and the way very successful companies look is, hey, if anything is possible, what can we do in 6 months? What can we predict? What can we forecast? Okay. I think predictive and forecasting reports or machine learning reports are a lot of the future. Okay. And they're also probably one of the hardest types of reports because, for example, how accurate do you want it to be? The more accurate, the more of a spread I'm going to give you. So if you want it to be a 90% accurate report, I have a real thin line. If you want it to be 99% accurate, I have to give you a really big spread because it could be between A and B. So it becomes very, very complicated. But again, they have the most value, at least in my mind. Then financial reports. Again, I talked about the financial team. I work with them often. A lot of their reports are how many hours, Excel format, how many people had overtime, how many people had training, how many waitresses called in sick, how many doctors prescribed X number of drugs, things like this. These are all those type of reports. Now, again, there are others, and you might not deal with all of these, but it's important to understand the type of reports there are because each one of them, you report out to different types of people, different management structures of people, and they expect different information. So, yeah, not all projects in the business world will have a clear goal. Look at my font change, or not font change, but different color. And this can create a ton of problems. So one way we talked about this a couple weeks ago was about the lack of talent, data inconsistencies, and more. Well, in the traditional brick and mortar world, there's Lean and Sigma 6. If you watch the videos, you learn about how Henry Ford came up with this to try to get rid of unnecessary waste. And one of the major problems, it seems, at least in my mind, is that there's so many great employees and they do great work, but when they get to information technology, when they get to business technologies, they forget that they're still dealing with a product and that there's ways to improve that product. That product has to move still, even if it's just information. That product needs skilled workers. It's not just pushing keys on a keyboard. So um, there's something called Lean Sigma 6. Let's go into that a little bit here. Lean Sigma 6 is a management methodology that combines the principles of Lean and Six Sigma. I always get that backwards, so I apologize if I confuse you on that. But Six Sigma to improve operational efficiency and quality. Ooh, that's useless information right there. It aims to eliminate waste, blah, blah, blah. So what is it? What are we doing? Okay. We look at a method. So somebody requests, I want to know how many steaks a waitress or this restaurant sold. Okay, and you start looking at it, and then we figure out, hey, this restaurant sold 100 steaks, but it used 120 of them. Why? Where did the other 20 steaks go? Well, 16 of them were cooked incorrectly, 4 of them were dropped. Okay, so let's interrogate why we had those mistakes. And maybe of the 16 that were cooked incorrectly, the waitress failed to bring out the steak in time, and it got cold. The customer wanted it heated up. And when it was heated up, it became overcooked or undercooked, whatever. The ones that were dropped, it was because 2 waitresses collided accidentally into each other and the steak fell off the plate. Okay, so we start looking at this in a physical world, and then we can try to transverse that into the digital world, into the data world. Well, you know, in terms of, hey, I have these databases, I have these questions, I have these reports. What can I do to ensure that my data is the same all the way through? Because at the end of the day, when somebody wants a report, they want to, in theory, improve that process. We don't check and monitor things we don't care about. I'm sure I have ants in my backyard or bugs in my backyard and birds in my backyard. I don't count each bird each day and try to figure out if I'm getting more birds or less ants or more ants. Why? Because it's not an area of interest to me. My GPA is an area of interest. So every semester I evaluate my GPA, I evaluate my process, say, hey, what can I do to become a better student? Because it's important to me. So reporting, the idea of reporting is that we're trying to improve a process. And this is where Lean Six Sigma comes in. I don't know whether to go to this one or the next one. Okay, so a lot of these terms are, I don't want to say nebulous, but they're not very specific. But what happens, at least what I hope happens, is when I took a Lean classes, when I took Six Sigma classes, I'm like, oh, this is useless. I'll never use this. 2 weeks later, I'm like, oh my God, why didn't I know about this 5 years ago? And that's exactly what I'm hoping happens to you. You know, I hope you maybe write this down, try to understand it. Then you're like, oh my God, why didn't I think about this earlier? Process efficiency. One goal is to eliminate waste. What does eliminate waste mean? Well, I'll show you. The very first lab I went to here at UNLV, the second lab I went to UNLV, they had a lab admin, a person that would do things for the lab. And we had 10, 15 students. Well, we were always going through paper. We'd have a stack of 3 or 4 sheets of paper, or reams of paper. And what would happen is once we ran out of paper, they would talk to the lab manager and be like, hey, we're out of paper. She'd order paper, and it would take 3 to 4 days, maybe sometimes a little quicker, 2 to 3 days to get paper. So in between that 2 and 3 days to get paper, we couldn't print out reports or journals or articles. It was a huge waste of time for a lot of us during that time. So what I did is I said, hey, let's just put this little tab, this little sheet of paper, when we get down to the last ream, and it says, hey, please order more paper, give this sheet of paper to the lab admin. So you take it out and give it to the lab admin. It says, please order 3 more reams of paper. So she ordered 3 more reams of paper, and now we're never out of paper. And all that person had to do was ever refilling paper was just take that little card and hand it to the lab admin. It increased efficiency by miles. Optimize the flow of information from data source to reports. Well, that's ETL. If you're querying some type of database a lot and having to redo your queries, you're having to redo your structures, you're having to redo your ETL process, why not migrate it over to a data warehouse? Why not see if you can get a DBA to help you and say, hey, can you pull this data every month? Can you pull this data every week? Reduce errors. So, oops, I didn't change now. I run a report, and one of the reports I run is, well, let me step back. So when we mail patients data, so we mail a patient, here's your medication, here is your information about your health, that's protected information. So if my company mails a patient or a customer incorrect information and it gets returned to address or some other person gets it, which happens, you move your renter and the new person gets your mail, opens it up, they call Southwest Medical, hey, I got this patient's information. We have to fill out a security incident. I hate filling these things out. I absolutely hate filling them out because there are a lot of paperwork, there are just a lot of questions, and somebody got a wrong piece of mail. So I have to now spend an hour and a half of my day to fill out a form. So what do I do? How can I reduce errors? One way I did it is by validating the addresses. So now I have a process that's literally automated that checks the day before we mail everything. It checks all the addresses, ensures the zip code is correct, ensures that the name is correct, ensures the address is correct. By doing this, let me find a piece of wood, I haven't had to fill out a security incident in almost 2 years. How can we reduce errors? I'll let you read the rest of these, but these are principles that not only talk about manufacturing, but also talk about digital processes, about reporting. We're going a little bit more to this. Okay, now there's one particular thing, MVP. MVP can mean a bunch of different things. It can be most valuable product. Now, I'd rather use a different term. One of the vice presidents told me this, and I fell in love with it. Minimally viable product. What is the minimum amount you can do to get it working? Well, what do you mean by that, Richard? Well, yesterday, I had a project, and I was helping a friend out, and it's going to take, I don't know, 8 or 9 weeks to do this process. It was a lot of work. I mean, 400 Excel spreadsheets, we had to do math, it was a nightmare. So I figured I could do the whole thing in Pandas and Python and kind of combine it all. So now there's two approaches to this. I define the problem. I have 407 Excel spreadsheets. Set the goal. I need to do averages on worksheet 2, column 1, 8, 9, 10, whatever it is. Okay. I'm going to skip the stakeholder analysis for now. Now, scope of project. Now, for that point is it a feasible project? Can I actually get it to work? Can I get it to do it? So what did I do? Did I try to figure out the average of all 10 or 12 columns? No. I had maybe 10 Excel spreadsheets in a subfolder. I calculated one average. That's not what the customer wants. Why would you do that? Because as a proof of concept, it's a minimally viable product. I could say, hey, look, I have these averages of these 10 or 15 Excel spreadsheets. If I do this same process and just grow to all the columns you want, column A, 10, whatever, AA, column D, if I grow to all the columns and I grow to all 400 spreadsheets, would this be acceptable to you? I wireframed it first. Trying my facial hair itches today. I created a minimally viable product. Would this work if I just made it bigger? They said yes. Then I made it bigger. So again, I just ran 10, one average. It worked. They were happy. So from there, I ran all 400 sheets, one average. Guess what? It worked. They were happy. Then I moved it out to all 10 averages on 400 spreadsheets. It worked. Okay. So this is a very, very important idea of the minimally viable product. Sometimes when people request data, and if they don't want a database, or let me rephrase it, when they don't want a dashboard, they just want some type of data pull, I literally have them sketch out with a pen and paper. I might even have a couple over there. What do you want? Hold on one second. Okay, you've all seen my writing, and you'll see more of it. My writing is the worst chicken scratch in the world. Okay, Here is a project I worked with on somebody, and I had them write out, hey, let's see if we can start here. What columns do you want? What would be the minimal amount of viability that I could provide you that works? And that's what they did. They just literally just wrote out, hey, I want this, da, 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 da. Once I have that, then I can collect the data. We can start measuring baselines. We can do everything else on this page. So that's a key issue. What is the minimal viability to get this project working? And once we do that, we can make it better. But let's figure out if it works or not works. Now let's go, I'll let you read the rest of these. We can go into detail a little bit more. That video from ASU goes into it. Now, when we talk about this class and the data science project, this class pretty much follows. I don't do model deployment really in this class, but everything else we cover. The collection of data. So what's a collection of data? Well, that's SQL. How are we collecting the data? How are we pulling the data? Most of the time it's, this type of database. It could be the Craigslist cards. It could be the synth patient data. I'm going to upload a couple more data sets this week. How do we get the data? How do we clean the data? Well, I don't want any Chevys are worth $1.2 million. I don't want any null rows. Okay. Next week, we're going to go EDA. EDA is just, as far as this course goes, it's kind of looking at the statistics, the light statistics of the data set. If I know I'm looking at Chevys and the average price is $200,000 for a Chevy truck, I know something's wrong with my data. If another example at work is I was looking at some type of scale or some type of machine, and I had some patients that were 4,000 pounds. And I know they weren't 4,000 pounds. I know somebody just typed in incorrect data. So that's EDA. So this kind of gives you that whole, and this is kind of the same thing here. Define, collection, measure, which is, you can't really clean without your measuring, analyze, EDA. Oops, let's go to this one. I know that UNLV's Leeds College of Business teaches this CRISP-DM. I've learned this in a couple CRISP-DM. It's the same basic idea. We have a business understanding. Remember what I said earlier? Who is this report? Who's your shareholders? Who's your stakeholders? Is this an ad hoc report? Or is this an executive report? Data understanding, data preparation. These are your ETLs, EDAs, pulling the data, cleaning the data. It's the same thing. Evaluation. Hey, I have an MVP. Will this do? I calculated the average for one column in all 10 sheets. Is this good? Yes. Let me do it on all the sheets. Same thing with this OSMIM. Same basic idea. Next slide, okay. So, big picture ideas, suggestions. What I hope to have you take away from this. If you want to watch more videos, I would suggest that Lean Sigma 6 videos, but try to find the goalposts. This is so important because often people don't know what they're asking for. They don't know all the metadata. They don't know all the dimensions of the data. Okay? And if you get stuck down in those weeds, you will never get to the goalpost. You'll never find, hey, is this okay? Okay, it is, but you want me to change what? Oh, okay, no problem, I can do that. But if you try to get every requirement and try to do everything up first, you'll never get to the goalpost. So, I take a much more agile, much more, hey, here's a product, how can we make it better? Here's a report, how can we make it better? Oh, you don't want this specialty, you don't want this? Well, you don't want total patients, you want total referrals. Okay, I can change that out on this little spreadsheet, no problem. Understand, again, what we just talked about. Often people, either executives, doctors, nurses, lower level worker bees, I guess is the best way to say it, or executive worker bees, they don't always know what they're looking for. They have a general idea, and if you can get them some type of product, they can revise it. Get close to the people and the data. Stay away from the middle. What do I mean by that? Well, there's something called zero distance. And what it is, hey, we're developing this report and we're staying in our cubicle and we're trying to figure out what the person wants. That's not the good idea. You want to go to the restaurant and figure out, hey, out of the 100 steaks that were served, 20 were dropped. You want to sit down and look and figure out why those 20 steaks were dropped. You want to understand why is there a problem. This goes back to Lean Six Sigma, okay? You want to get on the production floor. And the same thing is true even if it's a pure information systems, okay? Hey, I want to know what the actual manager is doing with the data. What is the 10,000 overfoot? What's his strategic plan with the data? Or what is the goals with the data? You want to stay away from the middle. Like I said, you just don't want to design it in your head and do all this work. You want to really get to the people that are inputting the data. You want to get to the people that are using the data and see if you can get away from just being one step distance or one distance away, whatever term you want to use. You want to be right there trying to understand that. And the reason for that is because you get context. What should be included, what shouldn't be included. You'd be surprised how people can find ways, not necessarily to cheat the system, but to go around the system, change the system, input data in ways they never thought were possible. I've seen some amazing people enter data in the most crazy way that I never thought, even after validation. I never thought they'd be able to enter, and they do. And the only way I know this is because I've been able to go on the line floor, on the production floor, and see people enter that data. Okay, so let's talk about the referral process I talked about a little bit ago. So we have a referral. Hey, you know what? You broke your arm, and your doctor says, oh, even better, I think you broke your arm. Let me send you out for a referral to an expert. Easy system. This is all electronic. One doctor sends an electronic referral to another doctor for a referral. Please have Richard Young x-ray his arms. Please have Richard Young's arm looked at for X, Y, and Z. And this is what I had to deal with. Look at it. Look at all the movement. You know, we talked about, let me pull up my lean notes. We talked about process efficiency. We talked about movement. We talked about reduction of errors. Anytime I move data, there's a risk of error. Standardized practices. Okay? User-centric approach. So, as a person with a broken arm, do I call my doctor? Do I call a new doctor? What happens? And this is, I'm dealing with this right now. I have a referral to a hearing specialist. And it's a nightmare because of a process just like this. The referral gets sent to the system. Then it goes in to make sure I have insurance. Then it makes sure that the doctor that wrote the referral really works here. They Google to check to see if the doctor is actually an MD or an APRN, what level. They literally go to Google and find this out. They go to IDX, which is just another like a scheduling system. Then they go back, and this can come from different services. It's just a nightmare. And the funny thing is, this is a very clean process, believe it or not. And it takes an hour and a half to process one referral. And there's so many ways that we can improve the system. And this is not just in medicine. This is with everything. I ordered Uber Eats 2 weeks ago, and the driver got lost. So Uber Eats canceled my order. Now, for some reason, the driver never accepted that cancel, or something happened with that driver. I was unable to order another Uber Eats for 3 weeks. Think about the inefficiency of that. I want to spend money with Uber Eats. Somehow the driver got lost. They didn't offer a replacement or anything else. I just said, hey, cancel it. I'll deal with it another day. They canceled the order. I don't know if the driver never accepted or what happened. But from there, I had to call back the next day. I called back 5 days later, the next Monday. And it was just a horrible process for something as simple as canceling an order. In a perfect world, it should look like this. Hey, we have an order. Something happened. It's canceled. We have acknowledgement, or we don't have acknowledgement of canceled. Move on. But instead, it looks like this crazy process. And it happens in business all the time in all different systems. Now this is just something, I know a lot of you posted this. There's a lot of different reporting tools. The two big ones, at least in my mind, and Google's coming out with I think it's Data Studio or Quick or Look. There's a bunch of ones. I used Domo before. I've used MicroStrategy. I still use MicroStrategy. Tableau I use. Microsoft I use. A lot of these we use. They all have the pros and cons. A lot of businesses like using Microsoft because it integrates with Teams, integrates with Excel, integrates with a lot of Microsoft products. That whole and a synergistic approach to Microsoft. With Tableau, maybe you need to come up with a different name and password. Maybe you need to come up with a different billing process to buy it. Microsoft, it just comes with part of the Microsoft tools. So always keep kind of an eye on these. Try to play around with a few of these different products over the next year because you really understand. For example, Tableau, one problem with Tableau, not a problem, but it is what it is. When I create a report and I want to automate it, so every Friday I send you the number of sales. Tableau can only send a PDF. And Tableau does that on purpose. Tableau feels that its job is not to email PDFs. Its job is not to email people reports. Its job is to create these beautiful visualizations. Well, MicroStrategy can email an Excel file. Not only that, it can add a password, like a password to the Excel file. So I can email you private information every Friday, and if somebody else gets that email, they can't open that Excel file. So there's a lot of different products out there that can do reporting. What else do we have? Again, we've covered a little bit of Tableau. I know last week or the week before, I gave you a template to follow, which click, 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 do that. Because that got your feet wet to how to use Tableau. Now I'm giving you more of the formal didactic education in Tableau. Those two videos will really help you. I'll upload some data sets. And where's that? Next week we're going to cover Python a little bit more into how to do EDL. I'll provide you a demo of Ultrex. I love Ultrex. They're a great tool. And I'll see if I can do a Power BI demo. I'll have to download it because I just reformatted my computer. So what else? Here's how you can get Ultrex for free. Learning tools for both. Oh, this is LinkedIn Learning. Tableau versus Power BI. Again, take anybody's comparison of the two with a grain of salt because we all have different values. 10,000 foot overview, in my opinion, Tableau can provide more focused analytics. Power BI can provide more Excel-based or quicker analytics all times. I think last week I had you look at some of the Tableau visualizations and post some of your favorite ones. I think I posted Josh Smith Force. He has a lot of great ones. There's something called Tableau Wizards, Ninjas. They're Tableau experts, and they do some of the most amazing things ever. I think this is one that, just to show you. I think we talked about this real quick. Let's see if I can make it bigger. Again, you can download this one. I guess that didn't work as well as I'd hoped. So if I want to look at all my sales for last week, I click on this. Boom, I have my sales. Ooh, look. I can tell as an owner, my profit for sales dropped last week. Is it because back to school? Why is that? Ooh, my sales and envelopes have dropped this year and this week. It's just long term. Let me look at this quarter. So I just hit Q. Ooh, both sales and profitability of envelopes have dropped. Let me check this month. You know what? I'm going to stop selling envelopes unless there's some other reason that you analysts can tell me I should keep selling envelopes. Same thing with chairs. While we're selling 7% more chairs this month, my profitability is down 33%. So am I actually losing money when I sell a chair? What about this quarter? Oh yeah, look at that. Inflation is just destroying my profit on chairs. So you can see how, just as a very simple analytical visualization, how this can be helpful. And this is just a very low level, very basic visualization. But it shows you that it doesn't have to be crazy. It can be very simple, very straightforward. Sales and profit being generated in 2023. So we talk about those. There's visit of the day, things like that. And one of the reasons I encourage you to kind of look at them is to get ideas, because you look at so many things and just small changes can make big impacts on the way you present your visualization. That forest visualization I shared, just the color of the paper and the font he used. That last visualization, it just had a thumbs up, thumbs down. Very, if profit equals, if week over week probably equals yes. I mean, you can download it and look. Then thumbs up. If not, then thumbs down. Very simple if-then logic. So there's Tableau, and I mean, Tableau is an expensive program. Ultrex is an expensive program. These programs, we pay 20 grand a year for me. It may not quite that much, but about 20 grand a year for me to use Ultrex at work. So these are very expensive programs. As a student, you have for free. Use the resources. So please download them, learn them, use them. So again, we already did the posting topic. So I'll send you out a demo. Remember to post on this week's topic. And then don't worry, you guys are all doing good. There's a couple more slides here at the end if you guys want to look at them. I'm not going over them, but they're there. Thank you. Please contact me if you have any questions or comments, and I'll help you out any way I can. Please watch the videos on Tableau and Lean Six Sigma.